Let's get ready to rumble, or should we say cloud? My name's Kevin. I'm a product manager at Tableau. And there's another Tableau in the another tabloid in the audience, my lovely wife, who is expecting our first #datababy.
And I am John Parton. I'm a principal engineer on the cloud infrastructure team at Tableau. Fun fact about me, I've worked at Tableau for about 2 years now, but this is my first Tableau conference, so I'm super excited to be here. You know, when I signed up for TC, I kind of thought I'd get some kind of cool, cush job like t-shirt folding or something. I didn't know. But instead, a series of really questionable decisions on my part has left me up here on the stage that looks like it would be more at home to a EDM concert than a technology talk. But here we are.
Okay, it's day one, and it's Cloud Day. If you're looking for more cloud content, stay right here. If you want to check out another session, this is my recommendation. So, quick show of hands. How many people are using cloud platforms? All right, keep them up, keep them up. How about AWS? All right, that's good. Azure? All right, GCP. Okay, all right, good. Great. This is about the ratio that we'd expected. Okay, another question. How many people are running production workloads in those platforms? Okay, a little bit smaller amount. Good, good. So for those of you who raised your hand, how easy was your migration up to the cloud? Hard? Easy? I mean, by the numbers here, it shows it's kind of hard to do, right? We're no different. Our cloud journey began around 4 years ago, and it's been a hard process. We're going to tell you about that. Scaling organizations in the cloud is not easy. So here's our evolution and our journey, and we're going to present you with some solutions that we built to help with those problems. So let's go back to 2015. Our cloudy roads were paved with gravel, and we had one AWS account. It was actually the first site of our Tableau Online, or our first home of our first Tableau Online site, US East 1. Is anyone operating out of that site? Anyone? One, all right, we got one, that's good. That was the first place. So first location, we also had some other applications like Checkout and Web Store. We had some early challenges running in the cloud. And with that one account, we had teams kind of stepping over one another, deleting other people's resources. Security wasn't always up to par. So we needed some governance, some guardrails to be put in place. So that's why in 2016, our team was formed. And it was simple, to give people self-service actions and provide governance guardrails where necessary. So we picked up our shovels, put in some asphalt, and put in a stop sign or two. In later 2016, Adam joined the company. And coming from AWS, he came with a rallying cry of put all of our infrastructure into AWS, or the public cloud. And at which point, every development team in AWS wanted to be there. But we knew we couldn't give them access to that one account. So we adopted with our partners at AWS what's called the MultiAccount Model. And this model is you have one environment per service or per service that you have. So let me give you an example. Let's say we have an analytics team, and our analytics team deploys Tableau. We would give them 3 accounts per the canonical environments. So they have a dev Tableau account, a staging Tableau account, and a production Tableau account. And you can imagine as you start to see our graph go up, the number of accounts and the number of consumption that we had started to trend upwards. I've hit the wrong button, just like you said. The multi-account was great, and it solved a lot of our issues with resource contention. But it also created some issues for us. And we worked with our partners in the early models, or the early days of the multi-account model. A lot of the automation wasn't quite there. So we had to build this. So our team went out to automate all the things. Automate how to get into the accounts or give accounts out, networking topologies, and access and security. We scaled our team up with a number of people, and also all the things. And you can see we tripled the number of accounts we had in 2017, and we also tripled our bill. And if you want to hear more about that, come to my talk on Friday. Our one-lane road was turning into a two-lane road, and we put in a median. And at this point, the middle of 2018, Tableau Online fully migrated to AWS. And our build pipeline that creates all the Tableau executables that you all consume moved into AWS as well. And we're seeing this trend continue in the number of accounts and how much we spend. It was a continued push in 2019, this year, and our team continued to automate a lot of the account provisioning pieces. A lot of the pieces, and we continued to tweak and tune the knobs for security to allow people that self-service actions that everyone wants in the cloud. We lacked some scale. At this point, we're hitting the next level of scaling issues. We were lacking visibility into the entire system. So, dude, where's that S3 bucket? For those of you who don't know what S3 is, it's a file store. It's a big hard drive in the cloud. At Tableau, we have over 400 AWS accounts. How do you find one S3 bucket? That's a hard problem to solve. The other question we were getting from our executives were things like, how operational excellent are we? Are we secure? So we boiled this down to, how mature are we, Tableau, in the cloud? How do we answer these questions? Our account governance is kind of like the DMV. It manages things like licensing and driver registration, for cloudy terminology. And it differs slightly state by state or account by account. Our team focused on individual accounts, lacked that broader visibility. We needed something like the National Transportation Safety Board, a system that looked out over the entire ecosystem. We needed a shared framework. So we thought about this problem, and we worked again with our partners at AWS, and we said, let's not reinvent the wheel. Let's use something called the WellArchitected review. For those of you working on AWS, have you heard of this model? Have you heard of this framework? For those of you who haven't, it's really similar to Tableau Blueprint. It's a best practices guide for you getting up and running and working in the cloud, and making sure that your architecture is well architected. And these are the core pillars of the well-architected review: operational excellence, security, reliability, performance efficiency, and cost optimization. And it looks to solve these common core questions that when you're operating. So, performing a well-architected review. It takes about 2 weeks to collect all the data, and then we perform an interview with folks. And it takes about 4 to 6 hours in a meeting, just kind of talking it out, what your architecture is. And we did it with a few teams. And it was a lot of work. And the outcome was a report, which gives you a task list, a punch list of things to address from low, medium, and high. As you can see at Tableau Conference, we've grown to over 20,000 people attending the conference. 4,500 employees work at Tableau, 21 offices, and our amazing dev team shipped over 180 features last year. That was not going to scale, and we're all about scale. And we're data people, low, medium, and high. That wasn't going to quite work for us. So we needed data, we needed to scale, and we needed a plan. So we developed the cloud maturity model, and we started with the WAR, the well-architected review. We wanted to programmatically grab these pillars or these items so that we could gauge how mature we are. We introduced a scoring methodology against these pillars. And we are going to continually evaluate the way that we build, deploy, and scale our infrastructure in AWS. And it's not as easy as like crossing the street in Vegas. And John's going to talk to you a little bit about how we did that. Watch my pen.
All right. All right, so how do we actually gather the data to put in our cloud maturity model? And how do we gather the data to answer some of these questions like, where's my S3 bucket? It would be awesome to answer the question with data, but how do we get the data in the first place? How do we get the data out of AWS? And this turns out not to be so easy for quite a few reasons. Just like highways and roadways, AWS has services and resources. And what you need to know here, if you don't already, is that AWS is huge. It is massive. There are hundreds and hundreds of services. And most people, if they've worked with AWS a little bit, have maybe heard of EC2 or S3 as we keep talking about. That's just 2 out of the 177 services. On top of this, there are dozens and dozens of resource types underneath each service. Resource types are things like, if you've heard of an S3 bucket, as we keep talking about, that's a resource type. The bucket is a resource type. Or a EC2 instance, that is another resource type. And the thing is, you need to know about the configurations of every resource within your account in order to understand if the service is being used securely and cost efficiently. On top of this, the data within AWS tends to be very, very highly relational. All of the resources relate to each other very heavily. So, and you need to know about all of these relationships in order to answer those really hard questions in a cloud maturity model or in cloud governance. So let's take a look here at our example. Let's say that you wanted to know which virtual networks within your environment were using which IP addresses. This is a super common kind of ask in a lot of security scenarios. In order to be able to answer this question, you would have to model, in your data model, you'd have to model 5 relationships between these 5 resources and probably quite a few more. So, how do we gather the data from this huge set of services with this pretty complex and highly relational data? It would be awesome to just maybe, can we just write a script and get it from the service itself? And honestly, that's what we did for a long time. We would write these ad hoc scripts to help answer these questions about our environment. But this suffered from quite a few problems. First of all, it's hard to reuse the scripts. So you write one script for EC2 instances, doesn't necessarily mean it's going to run all that well if you try to adapt it for S3 buckets. Secondly, these scripts tend to be really, really slow. You're collecting resource data from potentially thousands or tens of thousands of resources, and you're doing that across 400 accounts in the case of Tableau. This can be agonizingly slow to run one of these scripts. And then finally, how do you share the data that comes out of those scripts? It isn't, it's not really all that possible to just send your script around the org and expect everyone to run your script. So how do you solve this problem? Well, you might be thinking, hey, just put it in a database already. That's where it belongs. That's how you share the data. But let's examine that for a second. Let's examine putting all of this data into a traditional relational database. Okay, quick show of hands. How many people here work with relational databases? Okay, I would expect no less from this crowd. I mean, honestly, like we're a Tableau conference, right? But how many of you enjoy doing schema changes within those databases? I saw maybe a flash of a half a hand. Yeah. And that's what I would expect, because it tends to be a kind of a pain. Let's take a look at this example. This example is our virtual network to IP address example we were just taking a look at. Now, this is fine for a schema, but now imagine this schema scaled up for the thousands of AWS resources. It would quickly start to look something like this. And I'm really going to milk this graphic because this took forever. So on top of that, any time that AWS changed a service or a resource or even an attribute of a resource, you're on the hook for schema changes. I think we all love data in this cube or pavilion, whatever you want to call it, but not enough for this sort of labor of love. So how do we solve these problems? How do we pave over this particular set of gravel roads? Well, in the words of Doc Brown, where we're going, we don't need roads. We wrote a tool called Altimeter that seeks to solve a lot of these problems. Altimeter, at its core, is a fast and easy-to-use application for collecting AWS configuration data. And it is capable of scaling across thousands of AWS accounts, which works really well with that AWS multi-account model we talked about. So we kind of view Altimeter as very much like its aeronautical namesake. It allows you to gain kind of a view from above and see the patterns within your AWS data. Let's dive into exactly what Altimeter is. Altimeter is a Python application, and it is implemented on the AWS Lambda framework. And if you're not familiar, the Lambda framework is AWS's serverless technology, meaning you don't have to babysit any servers to run something like Altimeter. I won't go so far as to say that Altimeter runs itself, but it's really not that far off. Altimeter starts out with one Lambda process that basically kicks off a series of additional Lambda processes, one per account. So at Tableau, we have 400 accounts. There are 400 concurrent Lambda processes running to capture all of the resource data from an account. All of these account scans get aggregated into a file format called RDF, or Relational Data Format, and dropped to an S3 bucket. That data from the S3 bucket gets loaded into a service called Amazon Neptune. And Amazon Neptune is AWS's graph database service. How many people here have heard of a graph database? A lot of people. How many people use graph databases in production scenarios? Not that many, and we're getting there too ourselves, honestly. But graph databases, I want to tell you, are great for this use case for a couple of reasons. First, you don't need a predefined schema. You can add new attributes and new resources pretty much on the fly. And the second bigger selling point is graph databases are really, really great at nailing those relationships between resources within AWS, which is really crucial. And this is because graph databases actually have, at their core, they store each piece of data as a relationship. These relationships are called triples. And just like the parts of a sentence that we all learned in grade school, that was, I'm sure, real fun for all of us, they have a subject, a predicate, and an object. So here we have an instance. It has a name of Tableau server. Pretty straightforward. But because these relationships are at the core of graph databases, it allows us to answer these really complex questions in the areas of cloud maturity and cloud governance. All we have to do is query Neptune. So how do we actually get all of this data into a place like a Tableau Viz or something? Well, to do that, we wrote another small application that runs queries against Amazon Neptune on kind of a regular basis. These queries just put out normal CSV data to an S3 bucket. And then that data gets picked up by another small application that publishes that result set data to a service called Amazon Athena. Amazon Athena is a really unique AWS service that allows you to treat CSV data within a S3 bucket as a traditional relational database. And Tableau has a great data connector for it. So at this point, we can utilize and unlock all of the power of Tableau to help understand this data. So we publish a Cloud Metrics data source for our engineers who really want to dig into this data a little bit further. And we publish this Cloud Maturity dashboard for account managers and execs who want to answer that question of how mature are we in the cloud. And Kevin will demo that for you in a moment. So seriously, where is my S3 bucket? Where is it already? Let me find it. So this kind of a question, seemingly really, really trivial, was actually really, really hard for us to answer with across 400 accounts. But when all the data is now in one data source, it becomes trivial to answer. An engineer can dig into the data source and make a dashboard like this in under 30 minutes and know exactly which account an S3 bucket is in, what region it's in, and all kinds of other configuration details about that S3 bucket.
Thank you, sir. So like John said, we take that data from Athena, we connect it to prep, we do some unions with prep, and we cleanse it a little bit, and finally we get to Tableau. And I'm going to show you what the dashboard looks like. All right.
It worked.
It worked. We're not done yet. So this is Tableau's cloud maturity dashboard. So basically what we did was take all of the Altimeter, we did all the fancy things John just said, and we produce a dashboard. This dashboard is going to allow our teams to give a greater view into their accounts, and executives look into it overall. So you can see here are all the pillars of the well-architected review, scored. And as you float over one of them, it's going to give you a description of each one of them to give you a better understanding of what you're looking at. On the upper right-hand side here, it gives you a name of all the AWS accounts that you have. So right now, we're scoring AWS or Tableau as a whole. Let's say we wanted to go down to an individual team level. Whoop. The score adjusts, and we can get an account-by-account basis on what it looks like. And on the bottom here, we can also adjust these weights. If we want to have, if cost optimization is more important for your organization, you can up that weight, and the other ones adjust. The nice part is, let's drill into some of these. Say I'm a team and I'm operating in this account. Let's drill into security. At this point you can see a list of practice items we've come together with. There's best practices for operating. Backing up your EBS volumes or encryption, and we give a score for each one that aggregates up to the total score. And at this point, you want to say, all right, I want to go encrypt or back up all my S3 EBS volumes. You can either hover over to get the docs from AWS and give a best practices recommendation, or I can drill right in to all the lists of volumes that I can go back up right now. We're still working on the maturity model. It's new for us, or in the dashboard, but this is where we are today. So, what's next? Our two-lane highways at this point are turning into interstates. And like John said, we might be floating a little higher than the interstate. We're looking to create conversations and transparency with all of our teams, account teams, executives, et cetera. And say, maybe we want to remove keys for our cars. You know, we have the digital keys, we just get in, jump in, it drives away. Or in AWS terms, it's like removing IAM users from all of the accounts. Or what if we're building with electric engines or gasoline engines? Or in AWS terms, are you building an EC2 instance by hand, or are you using serverless technologies or containers? We're going to work with all of our teams to improve Tableau score overall.
All right, and I have a bit of a cool announcement to make. We have been working really hard to open source Altimeter. It's out there on the Tableau GitHub page right now. I got to get a shout out to John Michaelchuk. He has been the mastermind behind Altimeter, and he's worked really tirelessly to get this out there, and it's out there for you to check out right now. Right now, it's just the component that collects all of the AWS data from all the accounts and puts it into a graph database. So if you're curious about graph databases and want to see your AWS data in there, definitely give it a check it out, and give us your feedback in the GitHub page. All right, so in closing, we really want to say that cloud maturity is definitely a journey and not a destination. But the real key here is to enable a cycle of continuous feedback and continuous improvement towards cloud maturity. We hope that you've kind of learned that this becomes a lot easier if you can enable all of the cloud-enabled teams within your organization, the kind of 10,000-foot view of things with tools like Altimeter and Tableau. We thank you so much for your time, and we hope you have a great conference. And we're open for questions here in a second. I will say that if you can please complete your speaker evaluations, there's a really good chance that I might not come back next year as a t-shirt folder and I can speak again. So that would be awesome.